Hello, everyone. Good morning, afternoon, depending on where you're at. Welcome to our bioavid user training, where we hope to give you some input help with which you can improve your qualitative allergen workflow. I will start with a little introduction. So we at R-Biopharm, we are dedicated to safe and high quality foods. We have three department sectors covering clinical diagnostics, nutrition care, and where we are at also food and feed analysis. We are distributed worldwide, either with subsidiaries shown in green and also with distributors shown in orange. We offer different kinds of test systems for different fields. Of course, we as the food allergens, but we also offer test systems for mycotoxins, enzymatic analysis, vitamins, microbiology, or GMO, for example. So food allergies, which is topic of or today. So in general, is the consumption of food safe for the majority of people? Still 2 to 4% of adults and 6 to 8% of children develop a food allergy. And a food allergy is a malfunction of the immune system. The number of affected persons is still rising and decreased a lot over the last years. The reactions vary, can be mild, but they're also life-threatening depending on the allergen, its intake, and also the patient's situation. Distinguished to that are food intolerances. We're like the lactose intolerance. There is no immune reaction, but it is a metabolic disease where, for example, lactose intolerance, an enzyme is missing. Something in between, which is also always counting two food allergies, is the celiac disease. This is a combination of an autoimmune disease and an immune reaction against gluten, which impedes or affects the intestines. There are no international homogenized or homogene rules regarding allergen labeling. As you can see here on the list, the obligation to label allergens depends on the country. There are the big nine, like the US is calling them. Here in Europe, we have 14 allergens which are obliged to label, but as I said, depends on the country, and especially if you want to export, you need to check which country or in what needs to be labeled in this country. 2 weeks ago or some weeks ago, we had also a webinar about allergen management. This is also available free to watch on YouTube, but just as an briefly to say why to perform an allergen management, of course, for the consumer. So if you want to offer a free from food, it should be safe. And for preventing cross-contamination, you should perform an allergen management, and at the best from farm to fork, to avoid that you first recognize maybe a contamination at the later stage of the food product. And for manufacturer, of course, you use an allergen management, or you should implement an allergen management at the end to avoid recalls, complaints, and also consequently to avoid additional costs and to save the reputation of your company. Within an allergen management, you can do a lot of activities, and a small part is testing or using test systems. And one part of these test systems are lateral flows, which will be the focus of today's user training. But just to give a insight for what lateral flows can be used. So, of course, to check or prevent allergen cross-contact, to support risk assessment and profiling, support your supplier and raw material risk assessment. A very big application is to support your allergen control verification and validation, and also things like assess the efficiency of hand washing. Lateral flows are mostly qualitative, so you have a yes or no answer, so it's positive or negative. You can use it for different applications. On the one hand, for food samples, so are your ingredients contaminated? Can be especially used as an example for raw material screening or incoming goods control, or final product screening to check is there something inside. Of course, also for surface testing, for example, if the allergen residues were removed from the surfaces sufficiently, so is your cleaning program appropriate, and avoid to contaminate following food products, which should be allergen-free. And also for testing rinse water, so was enough water used to flush away the residues? So besides checking the plant, you can also check the water, like the last water which run through the plant after cleaning or during cleaning. So now we will hand over to my colleague who give a short overview of the methods before we go deeper into the implementation.
Thank you, Annalisa. So generally, there are different methods that detect allergen residues within different types of samples. So R-Biopharm offers 3 methods to detect allergens. On the one hand, we have the lateral flow devices, which will be the topic of today's online seminar, which provide qualitative results, but we also offer ELISA and PCR, which also give quantitative results. There are 2 main principles for allergen detection. The first principle bases on the detection of a specific DNA molecule, which is then amplified with the polymerase chain reaction, or also called PCR. And by adding different types of markers, for example, that intercalate with the DNA, the resulting signal then correlates or is then proportional to the DNA concentration. So PCR methods are highly specific, but they don't provide any information about the actual presence or expression of the allergenic protein. The second principle bases on the detection of the allergenic protein and thus gives information about the expression and the presence of the allergenic protein. And those proteins can then be detected by immunobased assays. The analysis of allergens by immunoassays also bases on 2 main principles. The first one is the sandwich principle, where the capture antibody is immobilized on a membrane or within a microtiter well, and specifically binds to the antigen or allergen, which is then present within the sample and added to the well or to the test system. By having a second epitope on the antigen, the detection antibody is able to bind to the allergen as well. During the competitive principle, the antigen or allergen is immobilized itself on the membrane or within the microtiter well, and by adding allergens within the sample, the immobilized antigens and the antigens within the sample, they compete to the binding sites of the detection antibody. So the detection antibody will, after adding, either bind to the antigen of the sample or bind to the antigen present on the membrane or on the microtiter well. Those detection antibodies are usually labeled. Within ELISA assays, they are usually enzyme linked, but in LFDs, they are usually gold or latex labeled to visualize the result in the end. Another note, within ELISA assays, after each step, washing step is followed, which has the intention to remove all unbound molecules present within the test system. And in the end of the ELISA, just the sandwich complex is present within the sample, or in the competitive principle, the complex of the immobilized antigen and the detection antibody will be there in the end. In LFD, there's no washing step, which means that all molecules that enters the test system will remain in the test system. And this may lead to some complications, but we will go into that a little bit deeper in a few more slides. So generally, the bioavid test systems have a detection antibody which is gold labeled, and the bioavid test systems provide qualitative results. In here, you see a typical setup of a bioavid test strip. On the left-hand side, you see the sample pad, which comes into contact with the sample. And after that, you may see three lines: the test, the hook, and the control line. The test line indicates whether the result is positive or negative, and it is based from the sandwich principle. So a sandwich complex is formed on the test line. After that, there's the hook line, which bases on the competitive principle. So the analyte is immobilized on the membrane in here, and the hook line indicates whether a high concentration of analyte is present. But we will come back to that in a minute too. And finally, the control line indicates whether the result in the end is valid or invalid when it's not present. On the right-hand side, you see the absorbent pad, which absorbs the liquid that entered the test strip on the sample pad, and thus generates a flow direction, which means that the analyte enters the test strip or the test system on the sample pad and then flows into the flow direction by crossing the evaluation lines towards the absorbent pad. I previously mentioned the hook line and possible effects that may occur during the no washing principle within the bioavid LFDs. And to explain the hook line and the hook effect a little bit further, we want to show you the following video.
Rapid test strips have been developed for the detection of low allergen concentrations. Color-labeled antibodies bind to the target allergen in the sample to form an antibody-allergen complex. The antibody-antigen complex binds to the test line and the colored band becomes visible. Each lateral flow test has also a control line. Consequently, two lines are visible in case of a positive test result. If a large amount of allergen is present in a sample, the strip becomes overloaded, and what is known as the high-dose hook effect occurs. High allergen concentrations result in excess of free allergens because there is a limited number of color-labeled antibodies and only a certain number of antibody-antigen complexes that can form. If the free allergens bind to the test line, no coloration or only a faint line will be visible because the color-labeled antibody is missing. The strip may be interpreted as negative because only the control line is visible. A false negative result on a sample with very high allergen concentration creates a considerable risk for the user. As a solution, an additional hook line consisting of the target allergen has been integrated. If there is a low allergen concentration, an excess of unbound color-labeled antibodies is present in the test. These color-labeled antibodies then bind to the hook line and become visible. As the allergen concentration increases, the number of unbound color-labeled antibodies that can bind to the hook line decreases. Consequently, the hook line intensity will decrease with increasing allergen concentrations. In the case of extremely high allergen concentrations, both the hook line and the test line will be absent. Note that the control line must be present in any case for a correct test result, and in combination with missing test and hook line, it indicates a highly positive test result. With the help of the hook line, a clear distinction can now be made between true negative and highly positive samples.
So I want to add a few remarks regarding the hook line. So the intensity of the hook line may vary upon different test systems and even depend on, even vary upon different batches of the same test system, which means that a faint hook line does not correlate with a high analyte concentration. The hook line is just due to safety reasons to prevent false negative result interpretation. So when the hook line is present, it will either indicate a negative result when the test line is missing, or it will indicate low to medium concentrations of the analyte when the test line is present. Also, for safety reasons, the hook line will disappear before the test line, which means that no hook line will correlate or correlates to a high positive result. And it doesn't matter how faint the hook line is visible in the end. When the test line is missing, the test result will be negative. So how to evaluate the bioavid test strips? As I mentioned before, it will be negative when only the hook line and the control line is present. So if no test line is present, the test will, or the result is negative. It is positive when all three lines are present, so the test line, the hook line, and the control line. And it is even positive when only the test line and the control line are visible, but this indicates a high positive result. When the control line only is present, it indicates also a high positive result, but in here the test should be repeated with a higher sample dilution. And finally, the test will be invalid when no control line is present. So R-Biopharm offers a wide range of parameters with regard to the bioavid test systems. We offer 16 parameters in total, and 15 of them include a hook line and are safe for use within allergen management in this case. The only test which has no hook line included is the bioavid lateral flow milk test, and this is caused by analyzing two analytes in parallel within this test. So in here, the analytes beta-lactoglobulin and casein are detected, and thus it is very complicated to develop a hook line with both analytes present on it. But if you want to make sure that you are on the safe side with testing milk, there's also a casein test available which includes a hook line. Next to the milk parameters, we also offer allergen detection for mustard, hazelnut, egg, and crustacean, for example. And all of our bioavid tests contain 15 strips, which means that 15 evaluations can be made, or 15 samples can be performed. Next to that, we also offer the RIDA Quick series, which are also lateral flow assays for detecting soy or gliadin. But these contain 25 strips. So what are the advantages of using bioavid? So on the first hand, it provides a reliable allergen detection, and you're always on the safe side because a hook line is included to prevent false negative results. Everything is included for hygiene controls. In this case, swabs and swabbing buffer are included, and you get fast and reliable results within 10 minutes. Because the application of bioavid is so easy, it is suitable for everyone, even for non-laboratory staff. As mentioned before, we offer 16 different parameters within the bioavid product series, and all of those parameters are extracted in the same kind of way. So you can extract one sample, analyze it for different analytes within the same sample. Next to that, it is versatile, so you can use the bioavid test for food testing, for example, by testing incoming raw materials. You can test surfaces by doing swab analysis to evaluate how good the efficiency of your cleaning procedure was, and you can test cleansing water. Next to that, we offer a simplified workflow. For that, you can download a free documentation app, the Reader Smart App Allergen, but we will focus on that at the end of the online seminar. And finally, the bioavid assays include a positive control, where you can check whether your test performance is good enough. In the next video, we will show you the proceedings, also how to implement and how to extract your different types of samples. So you will see that now.
Before starting with the lateral flow for detection of allergens, the sample has to be prepared. Use one vial pre-filled with PBS per sample. Moisten a clean cotton swab with the PBS. Swab the area of interest with a crosshatch technique diagonally in all directions. Release the sample from the swab back into the PBS vial by carefully moving the swab up and down and squeezing it against the vial wall. Liquid samples like sip water can directly be used in the assay. Solid food samples have to be homogenized and centrifuged or filtered before use in the test. After the sample preparation, note your sample ID and open the reaction vial. Add 3 drops of running buffer into the reaction vial. Add 0.1 milliliter of the prepared sample into the reaction vial by using one of the contained single-use plastic pipettes. Mix the content by carefully pipetting up and down 3 to 4 times or by carefully tapping the vial on the desk. Incubate for 5 minutes. Immediately before use, take an allergen test strip out of the strip container. Close the container again. Insert the test strip with the arrows pointing down into the reaction vial. Read the result after 5 minutes with the help of the evaluation card. Depending on the sample and its concentration, different line patterns can occur on the test strip. With a negative sample, the hook and control line will be present. The test line indicates the presence of the target analyte in the sample. A positive sample will lead to the presence of all 3 lines. Even if the hook line is faint or absent, as long as the control and the test line are present, the sample is positive. At very high concentrations of the analyte, the formation of the test as well as hook band may be blocked. If both the test and hook line are missing, the sample is suspected to be high positive. This sample must be tested again with a higher dilution.
So now we are going deeper into like troubleshooting or like critical steps during the implementation. So you have now a brief introduction to this topic and about the hook effect, and saw the video of the procedure. Here you have the flow chart, which just summarizes the procedure of the bioavid tests. And now you have some minutes to think about which steps might be critical during the test implementation. We have given you some alternatives, and some may be critical, some not. So feel free to evaluate and think about what steps may be critical. And in the next slides, then we will go through the procedure and name the critical steps and give some hints or recommendations. And of course, you can choose more than one, so it's a multiple answer possible. Okay, a lot of results were coming in. So as you all could see is that top critical points or steps from attendees' opinion is taking the swab and mixing the sample in the reaction vial. So to almost all steps we will come in the next slides. I just want to say something to the 5-minute centrifugation of the sample. So this is not a critical step. So this step is for separating like particles from the sample, and it doesn't matter if it's 2 minutes, if it's 5 minutes or 10. It needs much more centrifugation speed to really settle the protein. So with this 2000 xg, it is not critical if you would centrifuge it for 5 minutes. And also, as no one sees the point of 4 drops of running buffer added to the sample as critical, of course, you should always stick to the procedure, but 4 drops will probably not influence the result very hard. Yeah, so now I will move on and we will have a look at the different steps. So starting with the swabbing procedure, which was nicely explained in the video, it's recommended to perform this crosshatch technique, and also recommended is to use an area of 10 mal 10 square centimeters. Of course, this is not always possible because sometimes you want to check equipment or any corners. So just always take or swab as efficiently intense as possible. It is good to have this 10 mal 10 area, but it's not always possible. Wet areas should be swabbed with a dry swab, so you don't need to moisten the swab. But if you have a dry surface, you should moisten the swab as shown in the video. Very, very, very important is the flushing of the swab. So really try to flush it out, press it on the sides of the tube, so that as much allergen as possible is going out of the swab into the liquid. And this is general a critical topic. There were a lot of testings done which show that often the recovery, so if you have a defined concentration on a surface and at the end what you detect in the sample, in the liquid, is often only around 30%. So this is a general scientific fact. So that's why it's very important to really flush out the swab to really get as much allergen in the liquid as possible. Then As the next step of the implementation procedure or the test, you add the running buffer, 3 drops, you add the sample, and then you mix it. Aim of this step is to bring the antibodies in solution. So the reaction vial contains antibodies, which are dried, and by adding the liquid, you get the antibodies back into solution. So it is always better to use a pipette when mixing. So there you are safer that the antibody is released or is getting into solution. Of course, you also can do it by really tapping, shaking the well, but more efficient is by using a pipette. So that is our recommendation. And since there are pipettes in the kit, this we recommend really to do that. Quite new is that the antibodies which are dried in the reaction vial are colored, so in red. This is on the one hand for our production, a control to see that also in every reaction vial the antibody is pipetted and inside, but it can also be a visual control, but it is not like essential. So of course, if you would add the running buffer to the reaction vial and then mix, then it needs to color red. But most of the time you add the running buffer and the sample and then you mix. And depending on the color of the sample, it may be that you don't see a red color. For example, if you have a curry or spices which have a high color, then of course you will not see a red color of the liquid. And here is a very critical, so if there is not a sufficient solution of the antibody, so incomplete dissolution, this would lead to false negative results. So this is a very critical step. I see a question here, if 3 drops with a pipette is the same as 0.1 milliliter of the sample. We don't know yet, so we are doing currently testings. But we recommend to use the scale. So the pipettes have a 0.1 scale, so you can pipette liquid. So recommendation is to pipette it a little bit more and then press out until the liquid enters the 0.1 line, and then you can transfer it to the reaction vial. Reason is this drops to volume depends on how you hold the pipette. It depends on the pipette itself. It depends on the sample you are having. So a more thick sample may have a different volume of a drop than a very liquid sample. That's why we currently don't have this information. We are doing some testings. It may be that in future we also give alternatives with drop, but we don't know yet. So currently recommendation is to use the scale on the pipette. After adding running buffer and sample, you have the first incubation time of 5 minutes. During this time, the aim is that as it was explained before by my colleague, that an antibody-antigen complex is formed. This looks like this. So you have the immobilized or you have the antibodies in the reaction vial, which are dissoluted by the liquid. And if you have the allergen inside, this antigen-antibody complexes will form. So as I said, that's why the 5 minutes incubation time is needed. In general, this step is not that critical. So you should stay with the 5 minutes, because with this we doing our testings. We are defining the specificity. But if it is maybe a little bit longer, this is not that critical, because you only have a specific amount of allergen and antibody. They will bind in this 5 minutes, and there is no reaction taking place if you incubate it a little bit longer. So as always, stay to the times, but here this step is less critical. After incubation, the first incubation time and formation of this antibody-antigen complex, in the next step, the allergen test strip is added to the reaction vial, and you also have a 5 minutes incubation time. During this time, the aim is so the liquid flows up and the liquid passes the different test or the different lines, and on the test line, the formation of antibody-antigen antibody complex, so the sandwich complex, will form if the allergen is inside. Here, the 5 minutes incubation time is much more critical than the first incubation time, because if you incubate it longer, it may lead to false results, because there may be unspecific reactions taking place over the time. And again, this test strip is defined and specifications are defined with this incubation times and procedure. So summarizing, there are 2 incubation times of 5 minutes each. For valid test, keep this time, plus minus 30 seconds shouldn't be a problem. And the second time, as mentioned, is much more critical. So here really stay with the time. Coming to food samples, the next slides are relevant for all immunobased assays, so not only lateral flow, but also ELISA. So in general, you have a high variety of food samples. Also influencing the pipette drops, as I explained before, but also they have different compositions, and also critical always during immunobased assays is the sampling and homogenization. So always make sure to take a representative amount of the sample. If you know you have an inhomogeneous sample, then take more for sampling. Homogenization is very important. For liquid samples, of course, not that critical because it's easier than for really solid food samples. And also very important is the extraction. For ELISA, I don't know how familiar you are with test systems ELISA, if you're using ELISA and LFD, but for most ELISAs you have a extraction where you use specific buffers. So with an ELISA, you probably will have a better recovery of the protein in the sample compared to lateral flows, because lateral flows are made for a fast and easy on-point detection, and here you often only have like water-based extractions, and depending on the matrix, it better extracts the protein out of the food or not. So to give some information to that, so allergens are not purified proteins, so the allergenic substance is only part of an entity. So for example, egg, you have the whole egg, but only the ovalbumin or ovomucoid are the allergenic compartment which you want to detect. So normally, or allergens need to be chemically extracted before analysis. As said, in an ELISA, you mostly have a more efficient extraction than with a lateral flow. And also, can allergens be present in their native consistence, so as raw materials, or processed in food? And native and processed allergens also may show a different reactivity in an immunological assay. So here, just to give you an idea, on the left you have the raw material with this nature conformation, and then you normally process it into a food by heating, drying, milling, fermentation, or others. And this has an influence on the protein structure, on the matrix aggregation, and your final product looks or has a different appearance than the raw material. And then at the end, when you want to test your finished product, you extract it. Depending on the extraction, you have a different recovery or extractability. Like for a lot of ELISA, you use heating steps so that you better extract your protein. But as I said, for LFD, normally you don't have a heating step. You have a quite simple water extraction. That's why it's always recommended to test the final product with an ELISA, or if you do a screening with an LFD, to confirm it with an ELISA, because there you have really more efficient extraction. But in the case, for example, of raw materials, here the extraction is much more easier than in a processed food, and that's why lateral flows are often used for raw material incoming goods control. Also, very important topics or things to consider during immunobased assays are cross reactions and matrix effects. So in general, you have a specific reaction. So you have an antibody which you use in the test, which is specific for your target analyte, and this reacts with a specific protein. There are typical 4 to 6 amino acids which form this epitope. The closer the antibody matches, the stronger the antigen binds to this. But also the binding strength depends on the pH and the soil concentration. That's why often, but my colleague will come to that later, we recommend to neutralize highly acid samples. So because very high or low pH may impede the reactivity of the antibody. You have cross reactions. So cross reactions are also kind of specific reactions, but unwanted. So the antibody reacts with a similar protein epitope. This is usually present with proteins of closely related plants and cannot always be avoided. For example, with soy and legumes, or most Massad assays, even in ELISA or LFD, have a cross-reactivity to rapeseed because they are so closely related that it's hardly possible to have an antibody specific only for mustard and not rapeseed. And that's also the reason why there is no immunobased assay for celery, because celery has a lot of very closely related plants, and that you have not a celery-specific immunobased assay. And at the end, the matrix effects that are physical or chemical reactions of the target protein with the matrix. For example, unspecific reactions of proteins binding food constituents like polyphenols with antibodies. So they impact the extractability and also the recovery. But also to polyphenols, my colleague will come in some slides with recommendations and how to handle these types of samples. And yeah, we are already coming to this point. So in the next slides, my colleague will give some extract sample appearances. In the next slides, you are all again asked, please, to answer some questions. We have some examples of different sample extract appearance, and you should decide which may be critical, which maybe need further handling, just that you get an idea of which samples are not critical to use directly or which need further handling.
Yes, on this slide you see 9 different extract appearances that show different kind of characteristics. And I would like you to answer which of the sample extracts may be critical for the application within the bioavid lateral flow tests. I will give you maybe 2 minutes to answer and have a look on it, and afterwards we will dive into that in a more detailed kind of way. So thank you for your answers. I saw one hand rising for a critical step during clear extracts. So clear extracts that may be, for example, sip water or cleansing water, and those are not critical. So they can be used immediately within the bioavid test. Within the second vial, you see a sparkling, foaming, or oily extract, and these correlate, for example, with sparkling beverages or dressings. And regarding the sparkling beverages, they contain carbon dioxide. And to get or to remove this carbon dioxide, you can centrifuge or filtrate the extract, and this will reduce the carbon dioxide which is present in those extracts. When the sample is sparkling, you need to consider the pH value as well, and you may need to neutralize the sample prior use within bioavid, because extreme environmental conditions like the pH value, as my colleague also stated, may destroy the proteins or the antibodies, and thus will lead to false negative results. So pH adjustment is a quite critical step in here. And regarding foaming extracts, you can also centrifuge or filtrate it to get rid of the foam, but alternatively, you can just settle the foam for a few minutes and then take the aqueous phase for application within the bioavid test. When the sample is very oily, you can centrifuge the sample to separate the two phases, so the aqueous phase and the oily phase, and you can use the aqueous phase for the use within the bioavid assay. On this slide, you see on the left-hand side a turbot sample extract, and on the right-hand side an extract which contains particles. For example, turbot samples may be milk or juices, and particle-containing extracts may be, for example, herbs, coffee, or spices, for example. So the extracts which contain particles, there you can either centrifuge or filtrate it to get rid of the particles, because those particles, depending on how small they are, they might interfere within the test by clogging the membrane, for instance, and thus disturbing the run behavior of the liquid. Turbot samples can be easily diluted, but keep in mind, diluting the extracts will also lead to a loss of sensitivity. Considering viscous samples, in here, for example, some matrices contain food thickeners like xanthan, or even flour, cereals, or seeds may lead to a viscous extract. And depending on the viscosity, you may need a high dilution, for example, a 1:20 dilution to reduce the viscosity of the sample. And this also correlates with reduced sensitivity. Depending on which sample you might extract, for example, legumes or fruits, or even soy sauce, when you extract them, you will get colored sample extracts. And generally, they don't influence the sandwich formation, so the result will be okay, or the result is correct in this case, but those colorations might lead to a background within the membrane, and thus leads to an impaired visual evaluation of the test result. When you have a intense colored sample, you can dilute the extracts, but also keep in mind this might be correlated with a loss of sensitivity. The same or similar things correlate with the red coloration of the samples. In here, another factor plays in, because the evaluation lines are colored red because of the gold labeled detection antibody, and thus the contrast between the evaluation lines and the possible background due to the red coloration is reduced, and thus leads or may lead to a false interpretation of weak positive samples. In here also the results are not influenced, and usually the coloration has no effect on evaluation, because those evaluation lines are quite characteristic for the tests. So when you have an intense red coloration, you can also dilute the extract like all other colorated samples, and usually or sometimes red containing or the red colorated samples have a possible presence of polyphenols, which leads me to the limitations of the bioavid assay. As my colleague also stated, polyphenol and tannin-containing samples might interfere with the test because these are non-specific reactions and may lead to false negative results, for example. Next to that, samples containing a high amount of oil may also interfere with the test, and strongly acidic or alkaline samples need to be considered and need to be neutralized. And all those three limitations can be overcome by using the bioavid absorbent buffer, which is also available at R-Biopharm, and this will neutralize acidic or alkaline samples. It will make the extraction of samples containing high amounts of oil more efficient, and it will reduce the unspecific reactions of the polyphenols with the samples. Next to that, we also mentioned the viscous samples. Highly viscous samples may interfere with the run behavior of the liquid, and additionally, pure nuts might interfere with the test. And to overcome those limitations, you can apply a higher dilution, for example, a 1:20 dilution. And finally, there are highly processed samples, and those might have another conformation as the raw material, and thus one of the epitopes may be lost during the new formation of the protein, which makes it hard to detect the allergen with the allergen, which is specifically binding to an epitope. This leads me to the documentation of the lateral flow tests in general. So on the left-hand side, you see implemented test strips, which are positive or negative as indicated, and the sample pad and the absorbent pad, which I explained further, are still wet directly after implementation. Next to that, the evaluation lines, when they are stored for a few weeks or a few days, they will fade or darken over time. So there will be changes. And further, they are stored by cutting the wet ends off and gluing them into a lab book or onto paper and store them into a folder. And this is very thick and impractical. And to overcome this problem, we developed the Rida Smart App Allergen. And the following video will give you an overview about how to set up and use the Rida Smart App Allergen.
The Rida Smart App Allergen is available free of charge in the Google Play Store. Download the app onto your Android device. After installing the Rida Smart App Allergen, simply open the app and you'll be greeted by the Start screen. For using the app, an account is required. Upon reaching the Welcome screen, simply open the menu. In the menu, tap on Settings. Once in the Settings area, select Manage Operators. In the User Management area, navigate to Add New Operator. To modify or delete a user, simply tap on the icons Edit or Remove. Return to the Settings area. Tap on Settings. In the app settings, select between two workflow mode options. Standard mode, use this mode for documenting single test strips. Serial mode, select this mode when documenting multiple test strips. Then save your settings. Return to the Welcome menu. Initiate the documentation process for your test strip by tapping on New Documentation. First, start entering sample information. Begin by selecting the user. Next, enter sample ID or scan the sample barcode. This step on supplier info is optional. Then tap on Continue. Second, provide test kit details. Select product and article number, enter lot number, then tap on Continue. Third, capture sample image is optional. If a photo is not necessary, simply proceed by tapping Continue. However, if an image is required, select Take a picture. In this case, a desk surface has been swapped. As you can see, the swapped area is depicted on the photo. Proceed by tapping Continue. Next, a sketch of a lateral flow device and a frame can be seen. Position the smartphone above the test strip within the specified frame and take a photo of the test strip. Next, you access the Results section. Classify whether your result is negative, unclear, or positive. In this particular case, all 3 bands of the bioavid strip are visible and hence the strip was denoted as positive. You have also the possibility to add notes to your documented data. The sample report is now available as a PDF and can be downloaded or shared. Tap Continue to return to the Welcome screen. Then select Results. Here is an overview of the collected data. You can select the data of interest and generate sample reports as a PDF or CSV file. These files can be shared, for example, by email or downloaded to your Android device. Reports can be saved or downloaded as a detailed report, as a summary report, or as a CSV report. This is how an individual PDF report looks like. This is a summary of results available as a PDF document. If you have further questions, please contact us.
So to get shortly back to the question on the previous video, so dilution of 1 to 10 is correct, which means that 1 gram is applied of the sample and you add 9 milliliters of water to that. And that is then the final extraction solution. So finally, I want to come back to the advantages of the Reader Smart App Allergen. So it provides a mobile documentation, which is simple and intuitive with any Android device. So you can use a smartphone, you can use a tablet. It doesn't matter which device you will use, but important is that it has a camera because you need to take a picture of the test strip. Additionally, there is data management available, which will give you a detailed overview about your data, and you don't have to store the test strips manually within lab books or within some folders, and the results will be permanently recorded electronically. It will also increase the efficiency and saves valuable time thanks to the direct scanning and saving. And it is compatible with all of our lateral flow tests, especially the bioavid test and the Reader Quick allergen test strips. On the right-hand side, on the bottom, you see a QR code, which leads you to the Google Play Store, where you can download the app free of charge. And with that, we will lead you to the last questions. Feel free to answer them. We will give you 2 minutes and then we'll come back to you for the questions if you have some. So now we are at the end of the online seminar. Feel free to comment your questions below in the chat box and we will get back to them to answer them.
We also have some download documents on the left with some information and general allergen overview brochure, the starter guide for the Reader Smart app, and also a folder about the bioavid tests. And I will just already answered, or we already answered some questions, but maybe for those who didn't read it. So there was a question, is that if there's a risk of a hook line by mistake due to matrix effects. So this is not possible because on the hook line you have the target analyte immobilized, and only a specific antibody can bind. And you only see the hook line if the antibody is gold labeled, which it is in the test. So even if something different binds to the antigen, it will not be visible. So only if the gold labeled antibody binds, you will see a hook line. So by mistake hook line is unlikely. And there was a question when the soy test will be available. So it's planned to be launched approximately in June, so soon. And it is valid for native and processed soy.
And it has a hook line included.
It has a hook line. And if there's no centrifuge, you can also use the filter as mentioned. And we recommend a standard fluted filter with a pore size of 8 to 12 micrometers.
There is also a question regarding what should be a high amount of oil. What is the percentage?
Probably depends on the sample. Often if you're unsure, it's always the best to compare like the standard procedure and maybe with absorbent buffer or special treatment. And like what we always say, to verificate your specific matrix, we have a standard operating procedure for that. We also have a paid service where we could check your matrix yeah.
For example, those samples containing a high amount of oil might be mascarpone, for example. Or even different types of dressings when a high oil content is used in there.
Okay, so with this, we will end this seminar. We hope you have some takeaways. Potato chips.
I think it depends. So you need to check and compare the bioavid absorbent buffer extraction or the normal water extraction and compare the results and to perform some spiking to evaluate.
Always recommended. So if you have your sample, to spike it with this defined amount of allergen and check if you find this concentration or if it's positive. And if not, then as a next step, you could use like absorbent buffer, for example. And you're always free to contact us via our website or distributor or sales representative. And wish you a nice rest of the day. And see you maybe soon. Thanks a lot for
joining.
Thank
you.